Moin! Electroplating 3D prints is fun and it always works. Always, doesn't it? So let's electroplate together this The Witcher amulet, sparkling bright, step by step. I'll show you what you need, take a little bit more time for the individual sections and give hints what you should do and what you should better leave alone. Let's go! First, we need a 3D print that we can plate. I printed this amulet with my FDM printer as clean as I could, but to make smooth surfaces with a great finish, this is not enough at all. At this point, the resin printer is also recommended because it can print much smoother structures. Nevertheless, it is possible to smooth out the typical layers. And that is necessary, since we electroform only a few micrometers with metal, all irregularities are visible later. So get to work and roughly sand the print. I use an emery fleece for this. After that, don't forget to clean it. A great help to make FDM prints smooth are epoxy resin and filler. But primers also work quite well. After application, these are sanded and treated again. This goes on until the print is nice and smooth. Let's go for the primer filler. I think fine steel wool works wonderfully to smooth the sprayed on print over and over again. Cut off some and polish like a champion. The result should be no less smooth as you can see here. Let me reiterate how important this is. To seal small cracks you can use polyurethane paint. This can be applied well with an airbrush. Cleanliness is absolutely king when it comes to electroforming and electroplating. It is important that you work absolutely dust-free from now on. For this purpose, there are tack cloths, for example, with which you can bind dust and dirt from your prints. Now thin the paint a little with water and you're ready to go. Remember your safety. I always use a respirator, gloves, safety glasses and also a fumes extraction system. Everything ready? Then let's go! I apply it with an airbrush and then let it dry well afterwards. When it is dry after about 6 hours, we first take care of a plating holder. The print will be painted very thinly with conductive varnish and is then very fragile. That's why we do this before. You do not understand why? It all makes sense later. Take silver wire and pull it several times through steel wool. This removes the top oxide layer from the silver. Then wrap the wire around the print so that you can simply put it in later. We are now producing an airbrushable conductive lacquer. We need it so that the 3D print can be copper plated at all. There are many ways to do this, for instance graphite spray. I will show you here how to do it with conductive copper paint. I use an airbrush, copper paint, a mixing pot, nitro dilutant or acetone, a stirrer and a dropper. Now take the copper conductive lacquer and shake it as hard as you can. The paint is already very diluted and copper quickly settles to the bottom. You must constantly shake and mix so that this does not happen. Fill the dropper with copper conductive lacquer and acetone in the ratio of 1:2 into the mixing cup. Then stir the whole thing well. It should be very thin. Close the cup. I already told you about this, didn't I? Really, it is very important that you wear a mask. Also, make sure that the fumes are carried out of your room. Well then, clean your print, stir the paint and airbrush the print at high pressure. You can't really do much wrong. Make sure the paint is not too thick. You will notice that by the copper piles up on the print. You must avoid this in any case. Also, do not miss any spots, because no copper can be deposited on these spots later. Try to apply the paint evenly thick. After that, it should look like so. When you have done this, the most difficult part is over. Woohoo! Let's talk about electrolyte. This here is a ready-to-go copper electrolyte. It consists of water, copper sulfate and sulfuric acid. It also contains a brightener, which is actually exactly for this purpose. Sure, you can mix everything yourself, but I do not. Use acidic copper electrolyte, not alkaline, which is also available, so that the airbrushed prints become conductive when put in the solution. We'll pour it into a suitable vessel in a moment, but first I'll explain how the principle works in general. So that you can understand everything, I don't fill the electrolyte into the vat yet. It is so that I position two copper plates, the anodes, at the edges of the top. The sulfuric acid in the electrolyte dissolves them. The dissolved metal ions then travel in the bath by the current flow to the 3D print connected to the negative pole. There they then deposit on the conductive paint. The longer we leave the print in, the thicker the copper layer will become. For the current I use a laboratory power supply which I can regulate steplessly. I now connect the positive pole with the copper sheets using clamps. Make sure that the 3D print is as centered as possible between the plates. Then connect it to the minus pole. Now we can finally get started. When I poured in the electrolyte I saw that it was dirty. This is very bad for shiny and smooth surfaces and I will therefore filter it. For this I use a polypropylene non-woven filter and a funnel. Now that the electrolyte is clean, I will prevent it from becoming contaminated again quickly. I mentioned that the anodes are dissolved. This also creates a lot of dirt, which I want to collect. First, we clean the anodes thoroughly with steel wool. Then we make sleeves from the polypropylene non-woven and secure the whole thing with the glue gun. The anodes can now simply be inserted into these sleeves and all the dirt is collected. I highly recommend doing the same. Attach the sleeves to the edges of the bath and wire them as presented earlier. Do you remember the plating holder? Now we put the 3D print into it. We attach the whole thing to the copper rod and insert it in the middle of the bath. We also connect the negative pole to it. A frequent question is how much current should flow. There are calculations based on the surface of the print. For this you can open the 3D object in Blender and see the surface area there. But the currents that come out are not suitable for me. The conductive surface is so thin that it has to be electroformed carefully. Therefore, I always set the voltage very low in the beginning, around 0.2 volts. Leave it in for an hour. Then go for 0.5 volt. Wait again, 1 hour. After that, see how it looks. If everything's okay, increase to 0.8 to 1 volt for additional 4 hours. It is recommended to move the 3D print in the holder frequently, otherwise it will weld itself to the wire. Take it out and inspect the result. Now rinse the print with distilled water. From this point you can put it either in a nickel bath for 5 minutes, the process is the same but with nickel anodes and a higher voltage around 2 volts, or plate it with palladium using a galvanic brush. I will quickly demonstrate it. First you need to degrease the print. There are special cleaners for this, but the important thing is that it is free of residue. Then rinse with distilled water. We use palladium electrolyte and this is how it looks. Unspectacular. In the manual it says how many volts you should work with. As anode we use a graphite rod, which we put on a galvanic brush. This is simply a holder for the anodes. Then we wrap a non-woven over it and dip it in the palladium electrolyte. We connect the brush to the positive and the 3D print to the negative pole of the power supply. Adjust to the right voltage and move the brush in circular motions over the amulet until the palladium deposits silvery. Et voila, done! And that brings us to the end. I have tried to show that electroforming and electroplating depend heavily on cleanliness and the smoothness of the base surface. If you follow the rules, you can achieve shiny, smooth layers without sanding afterwards. I'm very happy with the piece and hope you liked it. Any feedback, just post in the comments, I'll be happy to answer. Moin moin!